Okay, good afternoon, everyone. We'll continue our discussion on multiple linear regression. I'm not sure if this is the same code chunk that I shared with you last time on loading packages like psych, pastex, OLSRR. Is it the same class? Kindly chat yes.
I think so, sir. Yes.
Okay,
Yes,
thank you. So this is one way to load your data, your package, even without installing them first. So you use the pacman package, and then we use the pacman load function. Okay, so I'm sure you have done this in the past already. Let me just run this. Okay, and then we were using the wage data set. Okay, so I have already loaded that. I'm sure you have loaded that already also before. So it's already here. Okay, I will dispense with the descriptive statistics and go straight to the stepwise regression that we were doing last time. So I created here, which is what we're supposed to do. I created the model where we regress hourly wage on all the variables, all our independent variables, education, experience, until number of dependents, and data is equal to wage. And as we learned, one way to write this function also is to just use tilde and then dot. The dot here means that we include all the independent variables. Okay, so let me run this, although I have run this before. Let me run that model. Okay. All right. Then we said that for stepwise regression, we can do forward using P values or forward using AIC. So let me just quickly review what we have done so far with OLS step forward using P class. So this is the function. This comes from your OLSRR package. OLS step forward, and then using the P value, we use the model, the regression model we just created, and then we identify the P value, what will make a variable enter the regression model if the P value is 0.05. And then I'll dispense with the details is equal to true because that's long. So I'll just print this class. Okay, I'll just print the final result. You can see here that the final result is there are 4 variables that will be included using the stepwise regression, and then it introduces the variable, okay, by one, introducing first the best among the predictors. In this case is education, and then tenure, gender, civil status, etc. So the adjusted R squared is 36. The Mallows CP is 6.2. The lower the CP, the better, just like the AIC, 2639. And the Ramsey, which is the root mean square error, this is simply error squared, so that makes the error positive, and then get the average mean, and then get the square root. So that's what you mean by Ramsey. So the lower the Ramsey, the better. So you can see here that adding civil status indeed lowered your root mean square error. Okay, so we can also use forward regression using this time AIC, and we learned that there might be a difference between the result using OLS step forward AIC and P value. That can happen. So if I run this, you will now see that for using AIC, you include experience. Okay, you include experience because based on AIC, the value of the AIC is lower. Although we know that the P value for experience is not significant. So you can see here the discrepancy between the P value and the AIC. Okay. All right, then we learned also about this, that we can plot the AIC, object with this model, and you can see here plotting AIC and step. It took here 5 steps, okay, which means that we included experience since experience lowered your AIC. Adding another variable will will increase AIC. Ake-Ike information criterion. Okay, I will dispense also with the details. And then we learned also about the backward regression, which is the more popular one. So here, we are using OLS step backward P. This one, it's P remaining. For a variable to remain, it should have a p-value of 0.05. So in this case, what we're given is what is eliminated. So if I run this, you will have this. So the first one that gets eliminated is race, indicating that this is the independent variable that has the lowest absolute p-value. And then you have your number of dependents and then your experience. So 3 variables were eliminated, which means those variables that are not included here are the ones that form part of your regression model. Okay, so we can also plot this details is equal to true. I'm not going there anymore. Okay, so also we can use the AIC method, OLS step backward AIC. And when we plot this, you'll notice that there are only 2 variables that were removed. Okay, only 2 variables that were removed. So it's different from the p-value P method a while ago, because here 3 variables were removed. And that's because with the inclusion of experience, the metric AIC became lower here, 2.6. Okay, what I meant was, yeah, even if we included experience, the AIC was lower. But when we included number of dependents, it went up to 2638. Okay, so we can also plot the AIC. All right, then we can also have this, just the general stepwise regression. So it makes use both of the forward and the backward. Okay, but usually the result of this is that it almost always agrees with the backward p-value. Okay, so I won't go here anymore. Okay, so we can also actually generate all the possible regression models. Okay, all the possible regression models. And here it tells us that there are how many all in all? 127 possible values. Okay, so let me just check. It's generated by, I think, 2 raised to the 6. Is it 6? Let me see. No, sorry, 2. There are 7 predictors. 128 and then -1. Okay, yeah. So the formula, if you have 7 predictors, you'll be able to know all the possible combinations of your predictors of your independent variables by raising 2 to the 7, and then 7 is the number of predictors. Since we have 7 predictors all in all, 2 to the 7 is 128, then subtract 1. -1, that will give you 127 possible combinations of all your predictors. Okay, here you have only 1 predictor, and then you can have 2, you can have combinations of all of them, 3, 4, 5, 6. Okay, so let me just go here. Here, 3, all the predictors there, and then 5, 6, di pa? 7, 4 predictors. So it's a pretty long list. And what it gives us is a list of your R-squared, your adjusted R-squared. We can actually, okay, so let's just, it's better to do this. We can so we created this object mod compare. Do you have this, class? Please let me pause for a while. Do you have this? I might be going too fast. Class?
Yes, sir.
Okay.
Sir, a bit fast.
A bit fast. Okay, but you have this, di ba? Yung mod
Yes, sir.
compare. Okay, so rinaran ko lang naman, class, no? So mod compare na yan, it will give us 127 models. Ano yung 127 models yun? Lahat ng possible combinations ng mga predictors yun. So meron yung mga model na iisa lang ang predictor, may models na 2, 3, 4, 5, 6 until 7, all the predictors are included. Then this can be converted into a data frame. Okay, so take a look at this. As that data frame, yung object natin ng mod compare, and then let's view this. If I run this, it will generate a preview here. Okay, mod compare. Okay, so all in all, 100. Okay. Okay, I wonder why. Bakit hindi niya binigay lahat, no? Okay, it only gave us the 7. Okay, I'm not. Do you have all the complete 127 list, class? I ran this a while ago. Generate a lot. Okay, anyway, it gives us a list of all the possible combinations of your predictors. And then andyan yung measure ng R squared, adjusted R squared, predict, this is the predictor, R squared, Mallow CP, AIC, Schwartz Bayesian information criterion, Schwartz Bayesian criterion, etc. No? Ang dami. I forgot what MSEP is all about, FPE. Okay, I'll have to check, class, the literature on the documentation for this mod compare. All right, but it tells us the possible combinations. In other words, imagine being able to print all the relevant information about all the possible sets of your predictors, but in just one code. Imagine doing that manually. It will take you weeks, 127 models. Tapos ililist nyo itong mga to, i-compute nyo pa yan. So it's really very convenient. Okay. Any questions about this, class?
Sir, ano po ulit yung code po? Mod compare is
Which one?
yung taas po.
Wala ba? Hindi ko ba nabigay ito, class? Ito?
Yan
Ito?
po, sir. Thank you.
Wala yan? Wala? Wala sa inyo?
As far as I know, sir, wala po.
Ay, okay. Sorry. Okay, akala ko kasi sabi niyo meron na eh. Okay, I'll share this with you.
Sir,
This one.
lumabas naman po sa akin yung 127.
Anong mod? Tinype mo to, no?
Yes, sir.
Lalabas naman, no? But I think I was not able to give that to you. And since we're in the interest of time, i-chat ko na lang to, class, yung mga codes na to. Okay.
Sir?
For us to save on time, yes?
How does that help us with interpretation, sir?
Interpretation, this is more on kasi may final model na tayo eh. So this does not really help us as far as interpretation. This only helps us in generating all the possible output. I don't know in what instance you might need to have those, okay? But this is more just a additional information about in case there's a need for you to generate all the combinations of your regressions, then R is able to do that. That's just what I want to say here. Because in Stata, hindi ko nakita sa Stata to eh. I'm not sure if Stata also has this, but I've been using Stata also for quite some time. Even SPSS also, hindi ko nakita tong functionality na to. No? Okay, but as regards the interpretation of your final model, hindi ito. It will not help us. It will not help us interpret. Actually, we already learned how to interpret the final model, right? So, pero ito, class, this is just additional features coming from the OLSRR. Who's that? Is that you, Del?
Yes, sir.
Did that answer your question?
Yes, sir. Thank you, sir.
Okay, sige. Okay. Sorry kung hindi ko na-link dun sa sa interpretation of the final model. This is more additional information. Okay, so all right. Okay, you can actually plot the object model compare, mod compare. Let's just run this very quickly. And then it will give us plots of, okay, take a look at this. It gives us plots of the model to use based on a particular criteria. Okay. So for example, let me, okay. So based on SBIC, okay, SBIC tells us that ano dito yung pinakamaliit na ano, medyo crude yung ano, no? Just crude, this is just a crude, this just gives us, hindi makita to. Okay. Yan, hindi ko ma-print ng buo tong ano eh. Okay, so for example, ito in terms of R squared, okay, it tells us that the best model is of course the one with 7 dependent variables. As we know, class, if you keep on adding independent variables, you keep on increasing your R squared. Okay, so this just tells us the number of predictors that's best if you're just considering the R squared. Okay, and we know that 7 predictors will be best, everything. Okay, but in terms of adjusted R squared, you can see, although hindi siya masyadong kita dito, but you can see the use of 7 is not the optimum kasi just the use of 6 is even better, no? In terms of adjusted R squared. You can see the drop here. Okay, but the diagram is not really that clear for us. Di ko ma-maximize siya, no? To really see which is the this is a graphical representation of the number of predictors that's best to use based on a particular criteria. Follow CP, this seems to point out, although it's not really that clear, it looks like 4 or 5 predictors. AIC also looks like 4 or 5 predictors. Okay, anyway, so that just tells us based on SBIC, it looks like 4. Okay. Since the SBIC already increases at this point, and then SBC also, it looks like only 3. Okay, the Schwartz Bayesian criterion. Okay, so again, these are just graphical presentations of the preferred number of variables. It does not really tell us which variables are to use. Okay. Okay, I already discussed this, the mod compare. All right. So we know, class, that from, okay, may question pa dito. Oo nga, but iba yung ano mo. Yeah, who among you, class, got the, ano, ito yung, Adele, kindly share your answer to, ano. But iba nga yung, ano ko, no? Wait, let me see.
I could share my screen, sir.
Yeah, okay. I'm supposed to have that also, eh, yung anong yan, yung, hindi lang Adele, wait. Am I missing a, no, that's not plot both AIC. Ito yun eh, plot mod compare. And then, sige, ano, 127. Yeah, that's for the model compare, no, Edward. We're referring to the plot ng mod compare. If you plot mod compare, class, what do you get? So sige, stop share ako. And then more, share screen. Oops, mali. Sorry. Okay, let me reshare. Share screen, and then share. Okay. I was expecting that kind of a plot also. Stop share. Sige nga, Adele, kindly share your screen, please. Okay. And who among you are getting this? Can you enlarge it, class?
Me as well, sir.
Ganito, no?
Yes.
Wait, So that's coming from the all step all, no? Okay. Ito, class, okay. What does this diagram tell us? You can see here the rectangle, diba? Well, let's go to r squared.
I actually got this warning, sir.
Sorry?
I got this warning pa.
Okay lang yan. Okay lang yung warning yan. Okay,
Sige,
but
sir.
yung the diagram here, class, I hope, let me first check, class, who among you got the same plot as Adele? Okay, so Edward, okay. How about the others, please? Okay. How about the others? Na-plot nyo ba yan? Hindi daw ma-load sa ano naman. Okay. So, sa akin lang yata yung iba, no? So, sige, discuss ko na lang. Adele, can you
Sige, sir.
maximize that image? Dito sa taas, dito sa baba ka. Dun sa sige. Upper, yan. Click that.
Sir. Can you see the image, sir, or do I
Di
have
pa.
to?
Sige, click mo siya. Click mo siya. There. Na-click mo na ba?
Yun lang, sir. I will reshare my screen.
Yan.
Thanks, sir. Yes, sir.
Okay.
How to enlarge it?
Sige, mukhang yung taas na lang, i-maximize. Ayan, sige. Yan na lang. Okay, let me explain this, class, no? So, for example, CP is Mallows CP. Okay, so this means that if you're only going to use one regressor, okay, it should be model number 1. What is model number 1, class? That's the list from your mod compare, and the predictor there is education. Okay, so it tells us that if you're using only one predictor based on Mallows CP, you should use model number 1. On the other hand, if you're using 2 predictors, use model 8. What's model 8? That's education and Adele, can you kindly show your mod compare the
Sige, sir.
data frame? What's model number 8?
Let me share my screen. Model number 8, sir. Ito po,
Yes,
sir.
yung view ng mod compare.
Sige, sir. Mod.
Yan.
Yes, sir.
Okay,
Wala,
view mo
medyo
siya.
malaki, sir.
I-view mo na lang. Para, yan, okay. So, take a look at model number 8. Di ba, ang number 8 is education and tenure. Tingnan yung class, no?
Yes,
Yan,
sir.
yan. That's model number 8, no? It's, so, R is telling us that if you're going to use Mallows CP as your benchmark, okay, as your basis for determining which model to use, then, and then if you're only using 2 predictors, then you have to use number 8, education and tenure. Those are the predictors that you'll be using. Okay? So, balik, Adele, dun sa diagram. So, ganun lang yung diagram na yan, class. It tells us if you're using 1 predictor, or 2 predictors, or 3 predictors, and if you're basing it on, let's say, adjusted R squared, then kasi may AIC, may R squared. Ano pa yung iba? Adele? Click that nga, please. So whether you're using SBIC, SBC, so it tells us already the model to use. Okay? Sige, balik na lang sa CP kasi ayaw mag-print ng ayaw mag-show ng Balik na lang sa second diagram. Okay. For example, for AIC, if you're going to use, that's let's say the 4 predictors, use model 64. Okay? If you're going to use adjusted R squared, so R squared definitely 127 to. So adjusted R squared 127 pa rin yata, no? Hindi lang masyado makita dito. Or that can be also 120. Okay. Any questions about that diagram, class? it just tells us which model is best to use if you're particularly in particular identifying the number of predictors and then a specific reference or benchmark to use.
I think, sir, that this diagram is just a more specific diagram compared to yours. Like they list out the numbers and all.
Oo nga eh. Yeah, but dapat ganyan eh. When I plot, usually nakukuha ko rin to. I wonder why. Sige, Del, thank you so much.
Thank you, sir.
Thank you for pointing that out. Okay, so let me reshare my screen. I hope everybody. Sorry. Asan na ako? Wait, share screen. Okay. I don't know why I'm getting this. Wala na dito eh. Okay, anyway, class, that doesn't really matter too much to us. Okay, so let's have a review. We know that the final model that we're using makes use of 4 predictors: yung education, tenure, gender, and civil status. Okay, based on what we discussed before. So let's now go to our, okay, and by the way, the performance package, which I haven't discussed with you, no? But this is a very important package. I find this really very, very powerful. We'll discuss more about this as we go along. You may wish to look at what can you find in the performance package. Okay, sige, i-ano lang natin, no? Double performance. Or dito na lang, class. Here, packages. Yes, Edward.
Sir, I think you made the mod compare first as OLS step best subset. Kaya po 7 lang po yung lumalabas. Can you try po, sir, yung mod compare muna ng OLS
ito.
na... Opo. Kasi kaya nagiging 7
sa
lang po.
subset na lang ako, no?
Hindi po. Subset po yung napindot niyo po ata before.
Kaya nga, ito yung pinindot ko kanina eh.
Opo. Same po kasi ng mod compare po yung name ng object.
Hindi ko pinalitan.
Opo, siguro.
Okay, itong all possible dapat, no?
Apa.
Okay, correct. Yeah, you're correct. Thank you. Thank you, Edward. So, ang ginawa ko kasi, class, nag-mod compare muna ako. Okay, yeah, that's it. Nag-mod compare ako. Okay, saan na yun? Okay. Ito, no? I should have plotted this. Ano lang yun? Ito. Yung all possible, no? Here. All possible, and then I'll plot this. Okay, I think I'll get this now. Yan. Okay, so I got it now. Okay. Ito kasi, Edward is correct. Nag-mod compare ulit ako, but this time, asan na yung mod compare ko dito? Yeah, ito, no? I'm using the best subset. Okay, best subset. So this is a different thing. I should have used mod compare 1 here. Okay, that would have been better to preserve this this all possible kasi dapat yung mod compare ko. Okay, thank you, Edward. Thank you. All right, so continuing, class. Where are we? Okay, so later on as we go along, class, we'll still look at there are several new packages that are being introduced. Ito medyo relatively bago tong library na to, performance na to. So if we, okay, di ba nag-generate tayo ng mod? Yung mod object natin, yung regression ng hourly wage on the 4 predictors. If we generate this model performance, it will give us a summary. Okay, summary siya ng ng mga indices natin, AIC corrected, BIC, R squared, a summary measure of all of this, and then plus, which we're going to discuss in a while. If I, do you have this class, itong codes na to? I don't think so, kasi dinagdag ko lang to eh. Do you have this class?
No
Not
po,
yet,
Yung
sir.
performance
Okay,
pa,
sige.
sir.
Alright, sige. Pakiano na lang ha. Sige. I'll share with you the codes para mabilis tayo. Sorry, kasi these are just recent things that I inserted. Okay. So there's a package called performance. Siyempre, install nyo muna to class. Or you can use the payload. No? Control C. Sabay ko na to. Okay. Control C. And then Control V. Okay, I didn't put the install.dat packages, so kindly just put that. And then we have this function check underscore model. If I run this, if you run this class, you will have these plots, which we're going to discuss in a while. Okay. Okay, so these are diagnostic plots that's important as far as multiple linear regression is concerned. So it tells us things about linearity, okay, linearity of our model. It tells us about dito normality na residuals natin, okay, hourly wage, density. Tapos ito naman yung heteroskedasticity niya, collinearity, variance inflation factor, normality of residuals, ito. Sorry, this is the hourly wage and okay, so I think this is more normality of your data. No? Okay.
Sir,
Yes.
the check model function is under the performance package po, no?
Yes, yes.
Sige, sir. Thank you, sir.
So sige, lagay ko lang dito for information performance. Okay. Okay, as I mentioned a while ago, meron ditong influential observations. There are some very relevant things that have to be discussed here, but definitely hindi natin kakayanin lahat i-discuss to, no? So let's see kung saan lang tayo aabot, no? Tapos your exams will be only up to that point. Okay, so for example, ito, no? This is a test to see if your residuals are normally distributed. Of all the conditions, of all the requirements for the assumptions in classical linear regression, let's say the least of our concern is the normality of the residuals, because studies upon studies in the past have shown that if you have a large data set, okay, then the normality of the residuals becomes of no consequence. Ito class, we can see here that may mga aberrations tayo above the QQ plot, no? Ito above the reference line natin. So this indicates something which we're going to discuss when we do some of it now, no? Okay. All right. So punta muna tayo dito, class, and I'm going to share with you some codes which okay. So let me first show you how we can write yung paper, kunyari, may paper tayo, no? O kaya yung sa case nyo, case number 2 nyo, which is multiple linear regression. How do you write the, in APA format, how do you write the observations? How do you write the inference? Dali, may question lang. Yung mod object natin, Edward, yun yung model natin kanina, no? Ito.
Okay, sir. Okay po.
Yung minodel natin, yung Ito yan,
Summary.
sa simula, yung so nasa line, ay wait, model yan eh. Asa yung mod natin? Here, sorry. Ito. I'm referring now to this one.
Okay, sir. I saw it.
Okay.
Thank you.
Nag-summary ako ng mod, no? Okay.
Okay.
All right. It's a regression model of the 4 significant predictors. Okay. All right. Then this is just one way to write your inference. No, we fitted a linear model estimated using OLS to predict hourly wage with education, tenure, gender, and civil status. And then I wrote the formula: hourly wage, regression, education, plus tenure, plus gender, plus civil status. The model explains a statistically significant and substantial proportion of variance. R squared is equal to 0.37 with F stat for degree of freedom 1, degree of freedom 2, 521. If you recall this class, diba? 526 observations. Degree of freedom 1 is the number of predictors, 4. Degree of freedom 2 is n minus k minus 1. 526 minus k, which is 4, minus 1, which is your intercept. Okay, and p-value is this one. Adjusted R squared is 0.36. Okay, the model's intercept corresponding to, okay, so here I defined what is the intercept, no? The intercept is defined by education is equal to 0, tenure is equal to 0, gender is equal to male, and civil status is equal to married, since they are the reference variables, female at saka married. Okay? And I defined it is at negative 2.16. Saan nanggaling yan? Ito yan, sa model natin. Ito. Saan yan? Ito class. Ito. Okay, di ba ang value ng intercept natin is negative 2.16? Ito class, no? Negative 2.16. All right?
Sir, so basically you're just interpreting the mods, sir.
Yes,
Mod
yes.
objects, sir.
I'm
Sige,
just
thank you, sir.
giving you a sample of how to write the results of your regression. Okay? Are you interested in having this copy, class? Hindi naman, ano?
Yes, sir, we are.
Hindi yata eh. Parang wala nagtatanong eh. So you're not? Okay, sige, tuloy lang ako.
Sir, wait lang.
Can we have the copy, please? Oh, may nagsabi din. Sige, i-share ko sa inyo to, no? Ito muna. Let's do this paragraph by paragraph. Shot natin. Okay, kasi magagamit ko rin ito, class, sa ano nyo? Sa, later on sa thesis nyo, if you're doing a model on, pero madalang na yung nagmo-multiple rin linear regression eh. Karamihan, kung regression, it will be panel. No? Okay, so ito naman yung individual effects, no? This is APA format. So kasi when you interpret the predictors, dapat may APA format yung discussion. So take a look at this. The effect of education, educ, is statistically significant and positive. Then identify ko dito yung beta. And then yung 95% confidence interval is, it's between 0.44 and 0.62. Okay? Makukuha natin, I'll tell you in the next, kung paano makuha yung confidence interval. Kasi dito sa natin, sa output natin, walang confidence interval eh. No? So, hindi sa atin binibigay yung confidence interval. Okay, although merong class control I, merong function na conf int, no? Okay? All right, yan class, oh. Yan, sinabi ko na. Confidence interval. All right? So, yung education natin is between 0.44 and 0.62. Let's see if that's what I used here. Ayan, class, no? Ayan. 0.40, si education is asan yan? .44 and 0.62. 0.44 and 0.62. Okay, yung confidence interval class ng model, and it will give you the confidence interval of your predictors. Okay, all of them should not contain 0 kasi significant sila lahat, no? Except for the intercept, which may include 0.
Sir, may I ask
Yes.
what's the point of a confidence interval ba?
Okay, so it means that kasi ang value ng point estimate lang kasi education natin, no? Our point estimate is 0.52 or 53. So how did we interpret this? We interpreted this as for every 1 year increase in education, there's a corresponding $0.53 increase in hourly wage, no? Ceteris paribus. This one is a point estimate lang siya, no? Statistically, okay, dapat ang natin, ang pag-estimate, it should be in a range, no? Okay, so ang sinasabi natin dito that we are 95% confident that the value of the marginal effect of education, of a 1 year increase of education in your hourly wage is between 0.44 and 0.62. Mayroon tayong 95% confidence na yung effect ng education is between that, no? 0.44 and 0.62. Remember, class, as I said a while ago, yung education natin, yung coefficient na yan, it's called a point estimate. Okay? Point estimate lang yan. So if we'll be very technical about it, and we're just using it kasi siya lang yung pinaka-mean, no? Siya lang pinaka-average. Okay, but technically, it can range between 0.44 and 0.62. Okay? Hindi naman kasi exact yan na 0.53. Okay? Okay ba yun, Adele? Clear yung explanation?
Yes, sir. Thank you, sir.
Okay, sige. Okay, thank you. All right. So also, ganun din dito, no? So sige, share ko na to sa inyo, itong sentences na to. Okay, sama ko na to. Okay. And then, there's a chat. Okay. There you go. Okay, so let's go back here. The effect of education is statistically significant and positive. Sinabi natin dito, class, yung point estimate, no, yung beta, 0.53. However, okay, if we want to have confidence about our prediction on hourly wage, we can have a range of values from 0.44, okay, to 0.62. With that, we can have now a range estimate also for our hourly wage, no? Kasi hindi lang 0.53, hindi lang point estimate tayo. And then we identified the t-stat and then the t-value, okay, the t-stat, 521 degrees of freedom, no? T-stat, and then the p-value. And then we also identified the standard beta, parang standard error siya, and then the confidence interval of our standard beta. It's just like the standard error or the standard deviation of your coefficient. Okay? All right. So ito naman si tenure, ganun din, no? Same pattern lang naman. Tapos ito yung natin, yung factor natin, the effect of gender. Okay? Male is statistically significant and positive. Okay? Take note, ang reference natin dito si female, no? So si gender, yung lalabas na doon, na beta doon, it's for gender. And it's of course interpreted in relation to your female. Okay, beta is 1.71, and then you also have your confidence interval between 1.19 and 2.23. And then same thing, your t-stat, value niya, p-value, standard beta, etc. And also the effect of civil status, single, statistically significant and negative. Beta is equal to negative 0.69. Okay, so pare-pareho lang naman, class, no? But at least there's a structure na APA format yung sabi ng mga details, no? Hindi na tayo manghuhula na paano ko ba kailangan ko ba i-report yung yung t-value niyan? Yes, you have to, no? if you're following APA format. Okay, so that's already a good reference for you to when you're writing your thesis in the future. All right, so tapos standardized parameters were obtained. So this is just a part of your discussion by fitting the model on a standardized version of the data set. 95% confidence interval, p-values were computed using a wild t-distribution approximation. Standard naman yan sa paggamit ni R. Okay, so, all right. So let's move here, class. Ito, wala pa rin kayo, no? So ito, I have to share with you. Okay? Sige, so para, all right. Hanggang dito, no? Okay. In the interest of time, Control C. Ay, sorry, hindi pwede masyadong mahaba. Okay, so let me chop that. Start muna ako dito sa, I forgot, hindi pa pwedeng mahaba masyado. 201 to 220 na lang. Yan, 201 to 219, Control C. Control V. Ay, hindi pa rin kaya. Ayaw. So, hanggang 210. Tanggalin ko, ano siya? Bigay ko na din. Control C up to 210. Let me do it by tens. Control V. Okay na. So, hanggang 210 yon. And then, let me go from 211. Continuation to class, ha? Kasi may LaTeX tayo dito, eh. Control C. Tanggalin ko na to. Okay, yan lang muna. Control C. Control V. Okay, may LaTeX equation dyan, class, ha? And then this one, hanggang, let's see, hanggang 230. Control C. Okay. And then 231 up to 244. Let's see, Control C. Okay lang, class, kahit hindi kung ano man abutin natin, no? Kasi hindi naman tayo nagsisprint. This is more of a marathon. Okay, quickly, let me go through the explanation of this one. Okay, so regression diagnostics tayo, no? Okay, model fitting is just one side of the story, class. After we do that, we have to check whether the output or the result of our regression model complies or is consistent with the assumptions of the classical linear regression model, CLRM. Okay, so yung diagnostics, ginagamit natin yan para i-evaluate yung assumptions ng classical linear regression model and investigate whether, okay, whether may mga data observations tayo na which exert large undue influence on the analysis. These are what we call sometimes outliers and also influence points. Yung outlier class, hindi masyadong problema yan. Ang problema yung influence data points because the influence data points indicate that they affect the coefficients. Okay, so by removing these influence points, it will tell us pwedeng malaki yung effect niya sa coefficients ng parameters natin. So pwedeng malaking pagbabago, no, ng model parameters natin. So that's what an influence data point does. So titinan din natin yan, class, in the course of our discussion. So once again, class, ito, ano ko lang to, no? Okay, di ba, class, yung linearity. Ano sabi natin dito? Wait, may question mark. Yung 2 to 3? Sorry, ano yung 2 to 3?
Dun sir sa ano po, after linearity number 1.
After linearity number 1, okay.
Bale, wala po yung number 2, yung homoscedasticity.
Itong dalawa? Wala to?
Hanggang 3.
Okay, sorry. Sige.
Okay lang sir, thank you po.
Ano lang, 3 lang? This one?
Yes sir, 2 to
Okay.
3 lang.
2 to 3. This
Yes,
one.
po.
Sige. Thank you.
Thank you
Control
sir.
C. Okay. Shut ko to, ha? Okay. Control V. There, that's 2 to 3. All right. So first class, sabi natin linearity. Sabi natin, we discussed this before already, linearity in parameters. The parameters must be linear. We're not talking about the linearity of your, let's say, in the predictors. Pwede kasi yung predictors natin naka-log, pwede siya naka-square root, pwede siya naka-1 over, doesn't matter. When we say linearity, okay, we mean that the parameters, okay, must be linear. And also, of course, nga pala, no? Ang first pala na pinapakita dito yung relationship ng independent variable natin at saka dependent variable natin. Because class, it doesn't make sense if you have, let's say, the function y is equal to x squared, no? So makikita natin parabola yon, di ba? Yung y is equal to x squared, right? It will be a parabola. So it's y opening, it's a U-shaped parabola opening upwards, no? So it doesn't make sense, class, to do a multiple linear regression model if it doesn't make sense to produce a linear model between y and x. Kasi quadratic yung relationship nila eh. So that's what we mean by the predictors, okay, and the response variable should have linear relationships. Okay? All right. And also, sabi din natin, dapat yung coefficients natin dapat linear. Hindi pa pwedeng let's say, beta squared, no? Or square root of beta. Okay? Now, may implication yan, class. Ano implication yan? So, yung linearity, class, ang implication yan is that ano yung expected value na x? The expected value of x is actually your mean, no? Okay, so the expected value of your epsilon, which is your error term given x, is that 0. It means that the conditional mean, the mean of your residuals should be equal to 0. So if you sum up all the residuals, class, you'll get a mean equal to 0. And then second condition is heteroskedasticity. Okay, so homoskedasticity. Dapat yung variance, no, ng error terms natin given your predictors should be constant. Yan ang ibig sabihin niyan. The variance, diba? Kasi ang heteroskedasticity, class, we're taking a look at the variance of your residuals. So the variance of your residuals epsilon given your predictor x should be constant. Yan, sigma squared, constant siya, class. Okay, also your error terms, okay? Okay, ano to? Okay, ayaw niya. Let me put a space here. Sige. I'll do this. Yan, okay? Ginanon ko na lang. All right. The covariance, okay? Covariance ni epsilon sub I and epsilon sub j given your x, given your predictors should be equal to 0. Okay, ibig sabihin wala dapat covariance yung sa mga residuals natin. Okay? All right. So also ito normality naman. Okay? I think we discussed this before, kaso nga lang hindi ko lang pinakita sa isang sa isang equation na ganito, no? So this is another requirement of your classical linear regression model. Dapat yung normality ng residuals dapat normally distributed siya with 0 mean and a constant variance. Okay. Number 5, dapat no multicollinearity. We said that before, dapat your predictor should not be collinear. Okay, hindi sila nag-aagawan kasi dapat sa pag-predict ni dependent variable. Okay? Number 6, no outlier effects. Okay? And then number 7, no measurement error. Dapat correctly measured yung mga variables natin, yung mga predictors natin. And ito, class, no specification error. What do we mean by no specification error? Okay? Ang ibig sabihin ng class, dapat complete yung natin, yung predictors natin. Kasi is it possible that, kunyari, yung model natin, wage and then education, wage, regression, education, is it possible that education and also education squared should be part of your model? Kasi pwede yun eh. Baka ang structural form natin, hindi lang education ang predictor. Baka kasama din dapat si education squared. Okay, so si tenure. Baka hindi lang si tenure, baka pati si tenure squared. Okay, so we'll discuss that, no, yung specification error natin. Okay,
Sir,
yes?
what if the data exhibits an exponential growth, sir? Is it still possible to use linear regression?
Oh, yun, that's a good question, no? Kasi pag exponential growth, okay. Number one, pag exponential, pag may growth na, then that means that most probably it's a time series, no, Adele?
Yes,
Kasi
sir.
when you're talking of growth, we're premising it on the fact that it's a time series. Kasi there can be no growth if your data is cross-sectional. Because it doesn't make sense to put order into it, no, pag cross-sectional. You can have your cross-sectional data rumbled, no? Pwede nating i-randomize yan. So walang problema sa sa model natin. So if we have exponential growth, then most probably it's a time series model. So that will not really work with multiple linear regression. Okay? So that's one, no? Ang ini-envision natin dito is not really exponential growth, but rather some parameters that could have been squared also. Kunyari, education. Kasi pwedeng may impact din, not only education, but education squared on your hourly wage. Kasi that's possible. So we're not talking of growth here, but rather the another functional form or structural form of your independent variable. Okay, so let me go back to my example. Kunyari tenure. Pwede kasing tenure, baka maganda kung nakasama si tenure squared, no? So in that case, then we will have a specification error. Kasi may hindi maka-capture dyan, which could have been captured by squaring one of your parameters, one of your predictors. So we'll have an example of that. Don't worry, titingnan natin yan, no? Itong specification error natin. Okay, but thank you, Adele, for that question. That's a very good question. So pag exponential growth, it will not be relevant as far as multiple linear regression unless we are using time as a predictor of your dependent variable. Pag ganon, then that could be an issue. No? Did that answer your question, Adele?
Yes, sir. Thank you, sir.
Okay, sige. Thank you. All right. So, bilis ng oras. Okay, regression. Sana tayo, no? Okay. I'll leave the others for your reading kasi ano lang naman siya, no? Self-explanatory din naman. Okay, we can make use of the glance function to take a look at your mod. No? Tingnan natin si mod. Glance natin. Okay, so here you have parang descriptive statistics siya, di ba? Di ba nag-glance tayo dati ng glance ng data set natin, and it will give us several descriptive statistics measures. Ito naman, glance natin is a regression object, no? Mod. And binibigay sa atin dito yung R-squared, adjusted R-squared, sigma, and I think this is the T-stat or whatever, the p-value, or F-stat yata to. Degree of freedom kasi 4 predictors, and then log likelihood. Okay, then we can use the plot. Plot natin si mod. Okay. All right. Then it's just like it's the same as sort of a bit the same as here, yung check model natin. Ito. Okay, ito naman plot lang. No? Ito check model from the performance package. Now plot is from base R, and then it gives us actually 6 plots. No? Take a look at this. Ito yung sana natin, yung focus ng attention natin ngayon. No? Okay. First we have this. So we're now going into our diagnostics proper. No? All right. First is residuals versus leverage. So what does this tell us? And how should your data look like? How should our plot look like? Kasi ang minomodel natin dito, class, leverage. Okay? Dali, hindi yata ito yung number 1. Okay. Wait, class. No? Number 4 pala yan. Sorry. Okay, let me go here. Okay, ito class. Take a look at this one. Wala ako. Okay. Ayaw. Ayaw niya. Yun na lang niya. Okay. Ayaw niya here. Then, ayaw pa niya mag-maximize, no? So this is your residuals versus your fitted values. Okay, tingnan nyo class, because this is a graphical illustration of heteroskedasticity. Okay, dapat class, ideally, dapat yung mga residuals natin plotted against the fitted values. So these are the predicted values versus the error terms, no? Dapat
Sir,
yung mga, yes?
I think you can zoom in po using Control Plus.
Sorry, Control Plus. Okay, thank you. All right. Sige, thank you. Oh, hindi ko nagagamit yung minsan, nakakalimutan ko. Okay, yan, thank you. All right, thank you, Adele, no? So you have here your horizontal line here. So ideally, class, when you plot your residuals on the y-axis and your predicted values on the x-axis, dapat wala siyang pattern, dapat random lang siya. But if you take a look at this, di ba yung sinabi natin, may fanning out, oh? Di ba? And there seems to be a pattern. Okay, there seems to be an increasing both positive and negative of your residuals as the fitted values increase. So when your fitted values increase, tumataas yung fitted values natin, yung residuals natin tumataas din, both negative and positive. Okay? So this seems to indicate that there's a pattern here. Sabi natin, dapat ang residuals natin, in order for it to be homoskedastic, dapat wala siyang, random lang siya. Wala siyang pattern. And there's an indication here that there's a fanning out. So makikita natin dito na it looks like may heteroskedasticity ito, no? But of course, we don't just depend on the plot because we can check this using a statistical, the Bruce-Pagan test, which we're going to discuss later. Maybe not today. Okay? Pero sige, i-ano natin yun, ha? Sige. Okay, okay, let me close this first. I-check na natin class, no? Oops. Okay, biglang nag-ano yung Okay, but yung tools nag-ano? Wait, sorry.
Pwede sir, control minus.
Ayaw niya eh. Sinusubukan ko kanina. Ayaw eh.
Sige sir.
Oo, sorry ah. Ba't biglang nag-ano yung I was doing control minus. Okay, sige. Ganito na lang para Okay. All right, sorry about that. So, I must have pressed something. So dito, just to indicate class, kasi yung plot 1 natin, okay, sabihin ko na to, no? Okay, it's used to check the linear relationship and also yung heteroskedastic distribution ng error terms. So linear relationship, a horizontal line without distinct pattern is an indication of linear relationship, and that is good. So we can mag-control tayo, control alt I dito. And I'm not sure if you have i-install nyo muna si LM o p-load na lang para diretso, p_load. And we have this LM test. No? So paki-load tong LM test. Okay, so naka-library na yan. And then we have BP, that ba siya? Wait, BP test. Yan, BP test. So this is coming from your LM test, no? Linear model test. Performs the Bruce-Pagan test against heteroskedasticity. Okay? Against heteroskedasticity. So, sige. So, ito, mod natin. No? So, we are checking the heteroskedasticity of our model. Ang null hypothesis natin dito, class, is that residuals are homoskedastic or have constant variance. constant variance, ibig sabihin homoscedastic siya. So if we want for the p-value to be greater than 0.05, no? Para we fail to reject the null hypothesis. Then run this. Okay. And what do you have here, class? Unfortunately, our p-value based on the Bruce-Pagan test, our p-value is much less than 0.05. No? Therefore, we reject the null hypothesis that our residuals have constant variance. Indeed, heteroscedastic nga siya. No? So dito pala makikita natin, class, na heteroscedastic na. And based on this statistical test. All right. So aside from the 4, actually class 6 to no. Ang pinaplot lang ni R 506. Anyway, sige. So 4 ang pinapakita dito, but may Cook's distance pa, no? Okay, so ano yung pangalawa, class? The second one here is ito. Normal QQ plot. So as I mentioned a while ago, yung normal QQ plot is used to examine whether the residuals are normally distributed. Okay, syempre gusto natin, class, na yung residuals natin are normally distributed, no? And it can be shown here. Okay. Sandali, may actually ito no? Siguro, class, for your information na rin, I'm going to post this kasi may file akong ginagamit talaga for diagnostics and it's using a different data set. However, since we use the wage data set, so it's logical for us to continue with that. So dito kasi, class, discussion ko dito, I'm using another data set. Well, it's a data set that comes prepackaged with R. Yung empty cars lang naman. So pwede nang madali naman i-ano yan. And then I have the discussion here, more complete discussion of your, kunyari, anong ibig sabihin ng residual versus fitted plot. Then may mga discussion ako dito, no? Okay, so it's quite a long discussion. So for example, okay, sandali, dito ba? Okay, dito pinakita ko, class, yung ano no? Okay, Control C, baguhin na lang natin ng konti. Okay, sorry, class, for anong nangyayari nito, parang I'm vacillating from one file to another. Kindly copy that. I just want to show you the power of ggplot. Control C natin, kakopy ko dito. Dito, no? So just to compare it with this one.
Sir, will ggplot be a part of our quiz pa?
No. This is just an add-on, no? In fact, yung basics lang naman ng ng diagnostics ang magiging part of the quiz. Since some of you were not my students in FINTSARK, okay. So data natin is, baguhin na lang natin to mod. Okay. And aesthetics natin, ang X natin is the fitted ng mod. Okay. Residuals ng mod plus geom point. Okay, the rest are okay. So ang pinaplot lang natin, class, is ba't na dalawa tong ano ko? I'm just plotting, yung data natin is the mod data, yung regression output natin. Ang x-axis natin yung fitted value. Di ba ito, class, itong plot yung mod natin, almost time na. If you write which is equal to 1, ang ipa-plot lang yan, class, yung una, no? This one, residuals versus fitted. There. Okay? And simple lang naman yung function, no? Plot mod which is equal to 1. Kasi di ba 5 yan, 5 plots yan. So yung una lang gusto mo i-plot, then which is equal to 1. Then which is equal to 2, which is equal to 3, etc. But you can also plot this using, okay. So just make sure that you change your aesthetics. So data natin is equal to mod, yung regression model natin. Ang x-axis natin will be the fitted value of your mod data. Ang y-axis natin will be the residuals, and it's just the residuals of your mod data. And then we're going to plot the geom point plus ito class, mag-aano tayo ng line, horizontal line, y-intercept is equal to 0. So dadaan sa y is equal to 0. Okay, dash line siya, color is equal to red. And then may label tayo. Sa x-axis, fitted values. Sa y-axis, residuals. And then lagyan natin ng GG title yung plot natin. So quite easy, no? It's layering. Layering. Okay, if we run this. Okay. So I find, of course, ggplot2, the plot of ggplot2 a lot better. No? Kasi dito kitang-kita natin class. No? We can really see the fanning out of your residuals. Saan ba yung ano ko? Okay, there, no? Hindi kasama yung ggplot class sa sa exam natin. Okay, kita natin, di ba? Nagfa-fan out yung residuals natin. Okay? I know class, I'm going quite too fast. Just one last minute. Okay? So, then you have your normal QQ plot, yung sa which is equal to 2 yan class. No? If we copy this one, Control C, and then dito, lagay natin dito, dito sa normal QQ plot natin, Control Alt I, Control V, okay, which is equal to 2. No? So this is now your normal QQ plot. If I run this, okay, yun siya. No? Okay. So how this goes, class? Ito yung ano, ito yung quantiles natin, theoretical quantiles. So if you have a normal distribution, ito yung quantile niya, quantile 1, quantile 2. So you can generate a normally distributed data. And then if you plot the theoretical quantiles, dapat close siya dito sa line na to, sa 45 degree line. Ito yung ano natin, yung residuals natin, we standardized it. And you can see that our residuals, tingnan nyo dito, class, ito. So you can see here that above the may tawag dito, no? Dito sa quantile line na to, hindi na normally distributed yung ano, yung residuals natin. So that's a problem with our residuals ng model natin. Okay? And you have 4 others, yung and then whatever comes next class, hindi kasama, but I would that you also look at this. Ito class, diniscuss ko dito yung ano, yung specification error. No? Ito yung Ramsey reset test. But that's not included in your exam. That will be part of our discussion in the next, ito yung sinasabi ko sa inyo class. Yun yun. Anong ginawa ko dito? Sinubukan ko class, baguhin yung model. Okay? Dito. Problema lang. Okay. Take a look at this model class. Nag-generate ako ng panibagong model. Alright. So take a look. LM, hourly wage, regression, education, tenure, gender, civil status, plus what? Okay. Ito. Education squared. Ba't nag-I tayo, class? Ba't nag-I? Kasi hindi magra-run yung kung edu squared lang. I'll discuss this next time. And then tenure squared. Kasi dalawa lang naman yung ano natin dito di ba? Dalawa lang yung quantitative variable natin. Next time, class, we're going to discuss this and I'm going to tell you that this is better than the original model. Okay, kaya nga pag nag-ano tayo specification test, no? Okay, it tells us that we have a specification error. Ito yung ano class, yung reset test na to. Okay, I'll just run this. Hindi ko pa pala nabibigay sa inyo ano. Pero never mind class, next time na lang. I'll just show you this. Okay, ito yung reset test na to. Okay. So, the null hypothesis here is that, okay, the model is correctly specified. Ibig sabihin, it correctly captures all relevant, even nonlinear relationships between the independent variables and the dependent variable. So here we reject the null hypothesis. Ibig sabihin, incorrectly specified yung model natin. May kulang yung model natin. Kasi ginamit lang naman natin yung 7, di ba? Tinanggal natin yung 3. And then, but we haven't checked class if possible na gamitin natin yung quantitative predictors natin, if pwede siyang gawing squared, no? Katulad nito, squared ni education, squared ni tenure. All right, so take a deep breath, class. Wow. Stop recording.